Good evening, everyone. Thanks for joining us. We welcome you to the Common Ground webinar series of Season 2 and Episode 2, brought to you by PMI India. I'm Vijay from Chennai, and along with me is Asha from Bangalore, and we will be moderating this session for you today. The topic for today's session is Reinventing on the Go, the path ahead for the automotive industry. And we are extremely pleased to have with us Mr. Jacob Kindangath, who is a Senior Vice President at the Robert Bosch Engineering and Business Solutions Private Limited. Mr. Jacob leads the business of engineering in electricals and electronics of vehicles at Bosch since May this year. He helps the OEMs with driver assistance, advanced features, vehicle electronics and safety, brake systems, multimedia, and infotainment. He has been with Bosch for over 20 years now and has handled diverse roles. Mr. Jacob is an electronics engineer. He spent the first decade of his career designing and integrating electronics at Bharat Electronics Limited and shaping up telecom and car multimedia at Bosch. He then took up leading roles in the fields of infotainment, industrial technologies for various types of applications and softwares, IT engineering and business solutions, and has led global marketing and sales. On the personal front, Mr. Jacob is a keen cyclist. We just got to know today that he's finished 100 kilometers and he still has energy to do this session. He's also a passionate photographer and an avid reader. He's always looked into market trends. Technologies such as machine learning and analytics that help with the connectivity of automotive excites him a lot. But without further ado, it is definitely our pleasure to invite our multifaceted guest speaker, Mr. Jacob, to this webinar. Just as a reminder to our participants before we start this session with the speaker, please use the Q&A box to type your questions for Mr. Jacob, and we will cover them at the end in the Q&A section.
Very happy to be here, project managers and the PMI patrons. Hello, everybody. I'm very happy to be presenting this topic to all of you. So in the next 20 minutes, I will use car as an example and just walk you through the automotive industry. Where are we today? Where do we think we will be tomorrow? And irrespective of the industry that we all belong to, listeners, I feel there will be something to learn out of the story that currently is in progress. So this is the second slide. So this is a car we have made as a concept car within Bosch. So this is how we feel the automobile will look after 10 to 15 years. So you see there is no steering and the people sit face to face. So it will be a huge transformation in the way that an automobile could happen in the next decade to two. So is it all about physical transformation of the automobile that we are talking about? So on the left, we have the first car that was produced by Carl Benz, and on the right, we have the modern electric car. This industry is beyond that. If you look at manufacturing, this is the one which pioneered mass manufacturing. Lean was brought in by Toyota. So there has been a lot of pioneering things that was brought in by this industry. If you look at the economy, it's close to a 5 trillion revenue industry and employs around 15 million people. And many GDPs, it contributes around 7 to 8%. And it has impact on industries like steel, oil and gas, finance. So it's a very multifaceted industry and has impact on our lives either directly or indirectly. So is this transformation that is happening in this industry all about the physical shape? No, it's much beyond. At the heart of it is what we call as a design transformation of the automobile. What is a design transformation? Let me give you an example. If you have been in the eras that we had only two cars, the Fiat or the Padmini and Ambassador. It was not the most reliable. Often you see that you'll have to push to start it. Now, if you see the automobile industry after Maruti came into India, the entire quality of this product has increased leap bounds, and the amount of choices we have has radically increased. How did this happen? Behind it is a big supplier base and the design process that goes. To get the quality levels, we have to rely on what we call as virtualization. So many of the validate. So when we're talking about the design of a car, almost 50% of the effort goes in testing and validating. So some of them are destructive tests like crash tests, some of them are non-destructive tests. So the design now has a high element of virtualization and simulation that you can actually test it out in a virtual environment before we finally produce it. So this has brought down the cycle times to a large level. So this is about the design transformation. So it's an integrated story, this making of the car. It's for an IC engine car, we are talking about 30,000 product. In an electric car, this is dramatically reduced. But in an IC engine, we are talking about 30K products, 1,000 plus suppliers supplying to make this product. And the kind of systems, processes, including IT systems that are required to make it happen is huge. The story of the automobile is beyond the products that you see here. The changes that are happening here is beyond these parts that has been displayed here. What is that change? How many computers do you think is there in a high-end car? So if it would have been a face-to-face discussion, I could have got a response, but in this maybe I will answer. There is a computer for every function, like power steering, engine management, brakes, your wipers. There are many computers in a car. A modern car has 100 plus computers. That's the kind of machine we are looking at. And often a car is looked at as a mechanical device. But that transformation which is happening under the hood is something that most of us who are as users may not be privy to. And what's happening here is, right now, as I said, we are talking about an architecture where 100 to 150 computers are networked on multiple protocols. It could be LAN, it could be CAN. There are multiple protocols on which these computers are networked. From that era, it is moving to an era where we are talking about around 10 microprocessor-based systems which will control the car. These are super powerful computers which are going to be there. Some of them need special cooling methodologies integrated in to cool because it produces so much of heat. And what this means is car as we know today is moving into a computing era and as a computing platform. This is a big change that's happening in the car. You would have heard about Tesla's architecture, but this is happening everywhere now. So more than a mechanical platform, this is becoming a computer platform. So lines of code is the way that we talk about complexity of software. Those of you in software industry would know this, but for the people who are not in software industry, one of the ways of expressing how complex the software is lines of code. How many lines of code do you think is there in a high-end car? And how do you think it compares with something like an Android operating system or a Windows operating system? So this is a picture of how it compares with different platforms in terms of software. 100 million lines of code is what we are talking about. Pretty much at the highest end when we look at even something like Google. And you see where a Boeing aircraft is and where a fighter aircraft is. So the other big transformation that's happening in this is it's a computing platform and a software platform. What does it mean, a software platform? Until now, we were supplying the computers as an integrated unit. That is, if it was a function for engine management, this used to be a box that used to be supplied to the OEs. This had the required computing power and the software integrated, and you give it as a box. Now, it's different. When you have a very, very strong computing power, the software is abstracted. So you have a scenario where the hardware is supplied by one supplier, different functional blocks of the software is supplied by different suppliers. All of this have to be integrated, tested. And finally, you need to have the safety levels that you expect from a car that you drive. So this is another big change that's happening. When you look at some of the cars, they say that it's like your mobile. The car gets, the software gets updated overnight. In fact, some of the cars that are there in market, the computing power that's required to run it as an autonomous car already exists. It is just the software update that is required. So what we call as flashing over the air. So your car, the way it works or looks like tomorrow would be very different from the way it looks like today because the software would have changed. That's the change that's happening in the automotive industry. I come to the topic of autonomous car. It's been a lot of reasons. Primarily, some of the driving accidents that have happened. What we don't realize is when we talk about autonomy of driving, we all think about driverless cars. That's the level 5 of autonomy. But already until level 2 are there in many cars, lane assist and parking assist, and until level 2, you have to have the hands on the steering. And it's after level 3 that you could take the hands of the steering, your eyes off, and of course in level 5 you don't need a driver. How do we achieve this? This is achieved with a set of sensors and an AI platform underneath. And this is where you need phenomenal amount of computing power to run this algorithm. The typical sensors that are used are the video, the radars, and the lidar. Now, there are two camps in autonomous driving. One camp strongly says that we can do everything with video and radars. There's another camp that says that that's taking too much of risk. We need lidar, which is a laser-based range detector, along with video and radar. Irrespective of that, this requires phenomenal amount of data. The way that the software is done for a autonomous car is not, the software is not written. It's all machine learning. For those of you who are familiar with machine learning and artificial intelligence, you know that it's a model-based approach to software programming. Once you make the model is trained. For training, you need real data. Like you would have seen Alexa in your home. Over a period of time, it gets better and better. It recognizes you. It learns new terms that you use. It can understand your accent. Similar here. Only thing is, if a car doesn't, an autonomous car doesn't function well, it can lead to disastrous consequences. So the problem here is what we call as a long tail. You may get 97% accuracy, but to get the last 3% accuracy, you may have to put in phenomenal amount of data. So there is a whole lot of people who look at the videos and then label the kind of scenarios that a car should understand, and this is fed back into the learning system, and then it's validated. So this is a very, very complex piece of technology. There is a lot of discussion going around with this. One thing is for sure, it will come. The timeline is very difficult to predict. When a level 5 autonomy comes, a fundamental business model of automobile will change. Those of you who like driving, start driving now because you may not get a chance later. Of course, in a scenario like India, we all talk about that it's extremely chaotic. what would happen is these kind of technologies also, when it can be introduced in some of the roads initially, and then it can widen up. But whether it's on the way, definitely when, difficult to say. The prognosis is from 2021 end to any time 2030. So where is what's happening to this industry? So you see the numbers. Uh, Most of us say that it has peaked. 98 million cars, automobiles were produced in 2017. Generally, all the experts in automobile industry agree that that number is not going to come back. That's pretty surprising, isn't it? That for a product which is still not penetrated in developing countries like India, like if you look at America, it has around 900 cars per 1,000 people, and India is around 50. Of course there is growth potential in India, but overall it's going to reduce. Why would it reduce? There are two or three factors. One is obviously the sharing concept. You know, for the amount of money that we put in an automobile, it gets used maybe just 1 or 2 hours a day. So rest of the time it's lying idle in a garage, or you even need to pay to put it in a parking slot. So the sharing model means that the capital expenditure is used much more amortized way. So that is coming very strongly. The Ubers, the Olas of the world is coming in. Second is, of course, what they call as the millennials and the new generation, how they relate to automobile. Maybe the aspirational aspects have changed. It's no longer an automobile which is aspirational, maybe an iPhone that is aspirational. However, with this epidemic and what could happen, there may be a shift because personal transport may come back. So it's very difficult to predict 100%, but generally the hypothesis is that it is going to stagnate. Now, if it is going to stagnate, what happens to the industry? Would its revenues stagnate? Would it come down? Not necessarily. I think there will be a lot of reinvention that would happen. The connectivity that car offers. Now, most of the cars that you buy are going to be connected. And there are a lot of, once a car is connected, it's no longer a product that is sold and then disconnected from the user. You are forever connected. So we are talking about this as your third personal space. The first personal space is home. The second personal space is your office. And the third personal space is car. So the idea is to integrate all of this and give you a lot of services on top of it, on which the auto companies can make revenue. So possibly the growth may not be high in terms of the amount of products, but the amount of personalization that would come in and the possibilities of services would enhance a lot. And here, I think there will be a lot of collaboration between different industries. And also, this is one place where you get amazing opportunities for the startups. It's going to be a future aided very strongly by digitization. As I told you, this whole thing of the lifetime value of a car or a lifetime value of an automobile is going to be around connectivity and digitization. As an example, we are talking about how can we make two-wheeler servicing. How can we get all the neighborhood garages on a platform, and how can we connect a user of a two-wheeler to a garage? And the way that we feel it could be done is if you can give a lot of value to the garage owner who possibly is running it out of a small shop. If he can get a better customer relation management and stickiness with the customer, he would come onto the platform. So there are a lot of opportunities here that we see once automobile has been sold, and this is going to be purely a digital game that we see. What happens to India? I think on India, One, of course, as I said, just 50 per thousand. So we will still see growth in automobile. Whether it's an electric, whether it's a gasoline or an alternate fuel. Of course, there are going to be challenges and there are going to be a lot of discussion around the environment impact and all of that. But we have to see that automobile is a mobility device. It is for the need of a person to go from point A to point B. Now, it can be achieved in multiple ways. It need not be done in the same way that we do today. So in India, we take leaps, right? We take technology leaps. If you see, for a long time, I still remember that I had to stand in a queue to make an STD call. And after a decade, everybody had a mobile phone. So we just move or leap over a couple of technologies. Same thing with the retail space. I was talking to one of the senior people in the retail industry and asked him, when would the large format shops come in India? So he was telling it may never come because India may go online. So that's the beauty about our country, that it sometimes leaps technologies, and even in this it may happen. We may get into a connected era, we may get into a shared era much more faster. That would also mean a lot of new ways that this business would come up. However, I feel in the next decade, we would still see the conventional mode of transport being used heavily in India. But a decade plus could see big changes that we can't even predict at this point of time. So this is a small slide. It's a difficult industry to predict. Over a long period of time, 100 years, the form factor of a car, the way that the car was aspired and owned, everything was constant. In the last decade, all of this has changed. The change fundamentally has not been driven primarily by the hotbeds of automotive industry like Detroit or Germany or Japan. It has been driven by Silicon Valley. And that's where the concept of autonomous car was very strongly propagated. The electric vehicle also originated. The Ubers came out of there. So all these new concepts has been outside in. How has the industry reacted? I should say that initially there was a little bit of a reluctance to get the bandwagon, but now there's a lot of investments happening here, and we will see a lot of new products, exciting times in this industry. Of course, it would not be like the earlier decade, but then it would also spawn a whole lot of new ecosystems, like how the mobile phone did. And so your dream and your thought is the limit. So for those of you who have not tracked this industry, I suggest you track this industry because it provides a lot of opportunities in terms of ideas and also opportunities. Thank you. That's all from me from a presentation. But then now we can get into a Q&A session.
A really interesting presentation. Thank you, Mr. Jacob. You mentioned about transformation in cars, both in the physical form as well as digital transformation. And also you mentioned interestingly about millennials. I would like to just quote a Deloitte survey that was conducted in 2020 that revealed about 64% of the Gen Z basically questioned the need to own a car. A few reasons that they quoted were soaring costs of maintenance and penetration of ride-hailing services such as Uber and Ola into the market. Now, this is a scene not just in India, but also, you'd agree, it's globally. Now, how in your view, the auto industry is reacting to this change in customer expectations?
Yeah, I told you this aspect is also seen in the stagnating on the sales as a product, as a number of automobiles on the road. However, the business possibilities only increase because what happens in a country like India is the chance of you using an automobile becomes higher. Finally, what do we want with this industry? It's mobility, right? You need to move from point A to point B. Now, until now, for that to be done in a personal space called as a car, you needed to shell out a lot of money. I mean, after a house, car used to be the device on which you spend a lot of money. But now, once it becomes shared, it's possible for a common man to get that. So it's more of opportunities. On the other side, when you look at mobility, mobility can be disrupted by a completely different technology. Now, what are we doing? Are we mobile? We aren't, right? So is telecommunication going to be a competitor for mobility? It can. Possibly it can. You don't need to move from if virtual telepresence come in and it's so good that you may not even travel. So it can hit many transportation sectors. However, it could also be the other way, right? We are talking about shared mobility. Now in this epidemic era, people are scared of shared mobility again. It may be a short term, but it's possible that again there is a trend towards wanting your own private vehicle. So these are trends definitely visible. Millennials, especially, I told you, they don't have this aspirational value around an automobile. But then I look at it differently. I do not look at automobile as only car. It is a possibility for a person to move from point A to point B, and we need to move towards an intermodal transport system where every mode will play a role, so that you get from point A to point B with the least cost, least eco footprint, and the most convenient way. So that's the way that we are also thinking. It's not only about car or automobile, but it's about getting a person from a point A to point B.
Thank you very much for that answer. So I have another question for you. Can you hear me?
Yeah, I can hear you, Ashish.
Yeah, okay. So, like you were talking about autonomous cars, contactless delivery, alternative fuels like octane and volcanol. In a scenario like this, what are the steps taken by the automotive industry leaders to face these scenarios? Any thoughts from you?
So, I mean, I can talk for Bosch, the company that I work for. If you look at the gasoline or the IC engines are going to be around for some time. It's not that we are going to have a sudden dip in IC engines and a takeoff of electric or an alternate fuel. So we are talking about a decade and a half where IC engines and the fossil fuels are going to be around. We are doing a lot of work to make it non-polluting. In fact, if you see BS6, the kind of targets that Government of India gave us to switch from BS4 to BS6 has never been done in the world before. And it was done by this industry in India, and we are all on BS6 now. And if you look at a BS6 car, the diesel technology, in some of the cities, the exhaust is much cleaner than the outside air because of the amount of pollution that is there. So that's the kind of technology we are talking about. On the other hand, this entire industry is moving, as I said, from the fixation of only a car as a product or a truck as a product to see how do we move goods or people from point A to point B the most optimum and eco-friendly way. And there is a lot of work going on in that, where we are talking about in the autonomous space that trucks can go back to back. So there is a requirement of only one truck which is moving up front. The rest of them align back to back, so you don't need drivers there, almost like a train wagon. So it's one industry where a lot of action is happening, and the leadership is seeing it from the concept of mobility as a concept and the eco-friendliness that needs to be brought in, and so that you conserve the environment.
Okay, thanks for that excellent and detailed answer. So, in a world of digitization, as you mentioned, the digital transformation is happening, and how can companies bring agility in their delivery? in order to aid digital transformation?
So I think this is a topic for project managers too, because agility is something which is an output of a very, very well-defined process. Agility is not something where you do things at the spur of the moment, right? It's about doing it in iterations and doing it in a very purposeful and process-oriented way. So you see that it's not about digitalization, but in any product cycles and complex products that is constructed, we used to use what we call as a waterfall method earlier. The requirements were frozen, and then you had design, and you used to construct it, and then you used to validate it. It's no longer possible like that, because as we make the product requirements are changing. So that's where the Scrum method, the Agile project management methods are extremely useful, and it's used a lot inside of the industry. The concept of digitization brings in challenge of business models that we operate in. So you would have seen recently, just last week, one of the car manufacturers was talking about giving their vehicles on lease. It was never heard. So you can take a car directly from that manufacturer for a monthly lease or a yearly lease or a 2 year. You don't have to shell out the entire money. You just pay as you use. So all of this requires platforms. It requires a platform-based thinking. You don't recreate it every time. You need, so the best example that I can think of is Aadhaar that India did. It's a platform, and you see the amount of benefits that it has given across when the UPID came in, Aadhaar is used. So we need to think platforms, and that is going to help us in agility rather than recreating. And automobile industry is a good example of such platform-based thinking.
Absolutely. Just to let you know that you've set the Q&A box on fire. There are so many questions that are flying in, and people are connecting with this webinar. I wanted to pick up three comments that have come. One from Shanta Kumar, who talks about digital transformation and autonomous cars. Likewise, Dhiren and Rajiv have stated about flying cars, their implementation in Japan and how incredibly popular it's getting around the world. And is it still in the conceptual stage, or could it become pragmatic in India at some point? What are the realistic expectations for us?
Autonomous cars, definitely it's on the way. The amount of money that's being put into by the industry is so big that we will see results. The date is very difficult to predict, but autonomous car is on its way. And the way it could happen is also that autonomy may happen in some of the tracks where it's controlled. It may not be that you go to Chickpet and run an autonomy car. It may be that in the national highways, you even there is something called as a car-to-car communication and car-to-infrastructure communication. So you can actually have smart roads. That's the way China is going. You make the road smart, and in that zone, the cars can be completely autonomous. So that those kind of things would happen. Flying cars. Yeah, of course. I mean, we already see it in sci-fi, and whatever happens in sci-fi happens in real life too. If you see, drones are already in, but it also has challenges. There are security challenges, right? So it's very difficult to predict, and how do you control this? I don't think it's not only a technology challenge that will come. It will also be a legislation, and how do you control it? So I don't see it happening at least 2 decades, because it's not only a technology challenge, it's the legislation challenge and the security challenge that we'll have to overcome.
Absolutely true. Absolutely true. I agree with you. I have another question from Sandhya. Now, without a doubt, pandemic has definitely accelerated some of the tech advancements, particularly in the automotive industry. which would normally take 5 to 10 years to develop, has obviously expedited itself, and they're looking at pushing it to the market. Now, the question is, how is the automobile industry dealing with this sort of an acceleration, and what transformations can we expect pretty soon?
So, one of the biggest change, as I told you, is that car has transformed from a mechanical-oriented product to a computer software-based product. Now, if you see, if you take the concept of AI or machine learning, these concepts always existed. It's nothing new. It was there decades back. These models existed. Why weren't they used? It's just because the computing power wasn't there. And now you see the computing power has, the Moore's law has still not stopped working. It still works. It is doubling every 2 years. So when the computing power increases, many of the problems that could not be solved earlier, we are able to solve it on real time. So here comes the disruption, right? If you look at the semiconductor industry, after the chips that we see, it has been made more compact, 7 nanometer, as the gate sizes are shrinking every day. What if quantum computing comes and you have, as much as computing power you want? Or what if 5G comes and you can have computing power somewhere and you can bring the data so fast? So many of these problems could be solved through disruptions that could happen in a different industry. So these are all tied together. It is not that it is solved by one industry alone. So it is a tandem that's happening. You have a cloud-based architecture now. Most of the products, including automobile, has a cloud-based architecture where a lot of data crunching happens in the cloud. So bandwidth plays a role. So these kind of disruptions is not only in the hands of automotive industry. It happens across, and one disruption leads to another. So this is how it will happen. It will not be only one industry specific. And similarly, automotive industry's innovations will be taken by other industries. So that's the way it will happen.
Thank you. Thank you very much indeed. Asha, you're on mute. We can't hear you.
Thank you for that answer. My next question is around testing for automobiles. This has come from Mohan Dalmia. He's asking whether the virtual testing is going to replace the physical testing for cars.
Yes, Asha. I think already we talk about concepts like software in loop, hardware in loop, where there's a lot of modeling that happens. Earlier, when I used to do development, I waited for the hardware samples to come, and then we used to we needed the hardware samples to test. Nowadays, it's not like that. It's parallel development that happens. The models are developed first. So you have the hardware model, you have the software model, and we parallelly develop on these virtual platforms. And when the real platform comes, you just calibrate it. The other part is, of course, what we call as crash testing. The cars have to be crash tested, and this is something that is to look at the safety features of the car. In fact, this brings in every validation cycle takes a lot of time. Because once a validation cycle is done, whether it's a reliability or a EMI, EMC or a crash test, then the results have to be taken and plowed back into the design. In a virtual environment, this gets shrunk. So instead of doing 2 or 3 rounds of real validation, you just need to do one. And it's a huge savings in money and in time. So it's something on which we are working a lot. either on both the component level, whether we are talking about ECUs, electronic control unit, or at the system level as a car. Validation is one place where there is a lot of virtualization happening, modeling happening, and a lot of investments in tooling that's happening. So I think if you are in the industry, you know already what is happening. Otherwise, we just read up a phenomenal amount of virtualization is happening in the testing space.
Thanks, Jacob. The next question is from one second. Yeah. So the next question is from Srinivasan. What will happen to the supplier and OEM? Right now, not only just the situation that we are in terms of COVID, but also we've had a slump in the market, and we're slowly picking up. So what do we envisage in terms of the supplier and OEM?
So the supplier and OEM relation is required in every complex industry. Because you have to cut the problem into smaller pieces and have experts working on it. That's the reason. Otherwise, obviously, one person can do it all, right? Why do you need to have suppliers? It's just the focus that's required to solve a problem. That said, there's always this debate in OEM as to which part should be given to supplier and which part should be done by ourselves. This is going to be a continuous process, and there would be calibration. Now, I think the ecosystem that existed in the IC engine era will not be the same as what exists in the electrical car era. That's because the IC engine was a very complex electromechanical product, while an electrical car is a much more simpler one. The number of moving parts in an electrical vehicle is almost 1/10 of what we see it in a IC engine. So this will definitely bring in a shift in the way what is done by an OE, what is done by a supplier. I feel irrespective of that, if you have a technology prowess, if you have innovation, every company will have a niche in the supply chain. You cannot be successful just because you were successful yesterday. So if you see a company like Bosch, it invests almost 8% of its turnover on R&D. And that is a significant amount of money that you are talking about plowing it back into R&D. And that is done just because otherwise you can't exist, because it's such a fluidic domain, and the technology space is moving so fast. I'll just give you an example. Until yesterday, when I say yesterday, I mean a few years back, the kind of competencies that you require to make an automobile was predominantly mechanical engineering. Now it is software, and it has shifted in the last decade in a big way. Now we need to see how we retrain. How do we reorient our workforce? If we do this, you will get an edge, and you will still be relevant in the value chain. If you can't do that, we will have challenges. So that's the world we are in at an individual level, at a company level. If you stop learning, you are there no more. Just because you were successful yesterday doesn't mean you will be successful tomorrow. That's the way that it's going.
Continuous learning is the key. The next question comes from Bijoy. What are the three biggest hindrances that is viewed in the autonomous vehicle journey?
Biggest hindrances, one is of course the long tail, the 97% to 99.99%, the amount of data that you require. It's the law of diminishing returns, right? To solve the last mile, you require humongous amount of data and processing power. So that is one problem. The second is what we call as bias. If you see assume a human being, we act and we have perceptions based on the data that we have consumed. If you are continuously consuming a certain kind of data, your perceptions change, your conversations change. As a person, you would be very different depending upon what kind of books you read, what kind of movies you see, what kind of people you hang out with. The artificial intelligence platform is also like that. It is a very raw platform. What it makes out is the data that has been fed. So the big problem in artificial intelligence is the data bias. It has even happened in a big industry lawsuit where a very famous company was using artificial intelligence for recruiting, and this engine was actually showing a bias, and they got into a lot of problem because it was not right. Similarly, the autonomous driving has this problem of bias. The data set has to be very controlled and diverse, so this bias is not there. The last, obviously, is the part of if a problem happens in the field, how do you say and how do you go back into the system and say it happened because of this? Because unlike a person made code, code is made by machine. So your ability to go in and understand it is limited. So this is the big three problems that we are facing: the long tail, the data bias, and how do you reconstruct a problem when it happens on the road. These are the big problems that everybody are working on.
Thank you for that detailed answer. The next question from Vyasarao and Shankar is around reliable batteries for electric cars and also the common swapping, the battery swapping technologies. Any thoughts on that?
Yeah, battery swapping technology will come in, at least in India. There's a lot of work happening in. It may not happen in the passenger cars. It may happen in the three-wheeler segment. It may happen in the two-wheeler segment. And right now, battery technology is the weaker link in the entire thing of a electric car. And the amount of weight to energy that it can carry is the big challenge. And of course, you know that some of the basic raw materials that are required to make the batteries are also a challenge. This is concentrated in some geographical areas. So people are also concerned that if there are some problems in these geographical areas or some countries do hold up these kind of resources, what could be the impact on price of a battery? Hydrogen fuel cell is another technology that is being looked in. It's very promising. We are doing some research on it. But this hydrogen fuel cell may be used mainly in trucks, not so much in the passenger cars. So the battery technology would be one of the crucial links which would go towards the success of electric car itself. And of course, the charging infrastructure, and if so many gasoline cars or IC engine cars move to electric cars, how do you get the amount of electricity that's required to power it up? All these are questions that needs to be answered, but right now I think it's too small that it has not impacted us. But even if it becomes 10%, all of this will start showing up. But I think there will be innovations that would come in this space. We should not think of this as a static world. There's a lot of work happening in the battery space. New technologies will come in. And if you see the curve of battery price to energy ratio, it has been exponentially coming down in terms of the price per watt that you want. So it's just a matter of time where it will take a leading, very strong cut over the classic fuels.
Thank you. We are a project management community, and the next question from Ramachandra Lakshmi on behalf of the project managers wishes to know how do PMs adapt to the new generation automobile development and maintenance projects?
Okay, this is, I've been a project manager myself. I have practiced project management, and I'm very passionate about project management as a science and an art. because it is a combination of three disciplines, right? You need to have a process knowledge, you need to have the domain knowledge, you need to understand the product that you're product managing, and finally, of course, you need to have good people skills. So it's a combination of these three, and finally, the beauty of a project manager is you get results. A business manager may get result or may not get result, but a project manager definitely gets a result in a given period of time. You see what you created. I was so happy that one of the products that I worked on was an infotainment system for a OE in India. Those days I didn't have a car, I had a bike, and when this system went into that car, I could see that, and I could feel the pride of the team in making it happen. To the product management community, the only thing I would say is keep yourself updated on technology. Of course, do not just think that having an understanding of the processes and have certification on the project management alone will make you successful. Because you need to have a sufficient grasp on the technology area that you are working with, and do invest in that also. Do not leave that part. Or I mean, it's like building up your body. They say that if you're going to the gym, your instructor would say that no, today it's a core, tomorrow is legs, this is the upper body. So otherwise, you will not look good, man. So only legs being strong and upper body not being strong, you won't look good. So all the three dimensions are equally important. Focus on technology, focus on the project management methods, that's also important. And of course, read upon people skills, psychology books, and soft skills, emotional intelligence, and those kind of topics. And together, it's really fun. It's a beautiful career to go after. I always tell it in my company that this is one of the most I mean, in my career, the time that I was a project manager was the time that I still remember very, very passionately.
It's been amazing listening to you, the wealth of knowledge that you bring to the automobile industry, almost everything covering the range from the physical part to the latest trends to what's happening in the automation and, what is the future of automobiles. It's been a great pleasure listening to you. So thank you very much. What you see on the screen now is the PDU code. Please use the PDU code and log in your professional development units for the PMI certifications that you may be holding. So please note that you would also get the PDU code by mail. So the next is about a quick preview of what is next in the PMI Common Ground webinar series. It is the leadership in the post-digital era, the next session by MD Srikanth NR from Accenture. He's the managing director, human resources, and it's an interesting topic too. Leadership in the post-digital era, happening on the 12th of September. So would expect to see you all again in that session. And thank you very, very much for the wonderful sessions, Jacob, and the audience.